Hi subscribers, welcome to our channel. This is Kishore Palavalsa. Please subscribe our channel for more information as well as for more gaining of knowledge. Okay, as well as I need your encouragement also, as well as I need your support also. Okay, for the different types of new concept oriented classes also. Okay, so today now we are going to discussing about different types of generated EMFs for the DC motors. Different types of generated EMF equations for the DC motors. Okay, in the previous sessions already we are learning the different types of generated EMF equations for the DC generators. Different types like series generator, shunt generator and compound generator and separately actuated DC generator. All those things we are learning the before session. Okay, so before class. So if you want to see that, learn the different types of all those EMF equations, so once go through our channel, please visit the before class. Okay, so now today we are going to discussing about general EMF equations for the DC motors. Okay, so let's now general EMF equation for the equations for the DC motors. Okay, DC motors. So coming to the general EMF equations. Okay, so basically according to the DC motor, according to the connection of both armature winding as well as field winding, both armature winding as well as field winding, which is both either in series or either parallel. So they can be classified into basically two types. Basically they can classified into two types. One is the self-excited DC motor. One is the self-excited DC motors. Okay, which is very important. And second one is the separately excited DC motor. And second one is the separately excited DC motors. Okay, separately excited DC motors. Okay. So coming to the here. Okay. So coming to the self-excited DC motors. Okay. So according to the connection of both armature windings and field windings, in that self-excited DC motors, they can be classified into three types. Basically they can be classified into three types. One is the DC series motor. One is the DC series motor. Okay, and second one is the DC shunt motor. And second one is the DC shunt motor. Okay, and third one is the DC compound motor. And third one is the DC compound motor. Okay, all those different types of generator concepts already we are learning in the previous sessions. Okay, so please, if you want to learn all those things, please go through our channel. Okay, please daily visit our channel also. Okay, so which is very important concepts and also which is very useful for you. Okay, so coming to the here DC motors. So DC series motor, shunt motor and compound motor. Okay, in case of separately excited DC motor, so in this only one machine is there. Okay, so here we have to basically separately excited DC motor means here we can separate are also called as some isolate to the both armature winding as well as field winding, and also here we are giving the excitation to the separately to the both armature winding as well as field winding in case of separately excited DC motor. But in case of self-excited DC motors like DC series motor, like DC shunt motor or DC compound motors, here both armature winding as well as field winding which is connected to either series or parallel, means here total combining the total windings, both armature winding and field winding in case of these type of machines, but separately excited DC motor is different. So in that both windings are separately, both armature winding and field winding separately in case of separately excited DC motor. Okay, so coming to the DC compound motor, in the DC compound motor, according to the construction of windings, according to the construction of both field windings as well as armature windings, in this they can be classified into two types. Okay, one is the DC long shunt compound motor. One is the DC long shunt compound motor. Okay, one is the DC long shunt compound motor and second one is the DC short shunt compound motor. Second one is the DC short shunt compound motor. Second one, DC short shunt compound motor. Okay. So in the DC compound motor, basically two types. One is the DC long shunt compound motor, as well as second one is the DC short shunt compound motor. DC short shunt compound motor. Okay. DC short shunt compound motor. Okay. So coming to the DC series motor. Coming to the DC series motor here. Okay. Coming to the DC series motor. Okay. In DC series motor. Okay. In DC series motor. So coming to the construction. So first of all, we have to represent the rotor. First of all, we have to represent the rotor. Already know that in the previous generators, we have to indicate the total diagram representation. So both winding representation as well as both diagram representation as well as both sign notations. Here also we have to represent it like that. But here the sign notation is entirely different from the generator concepts. Okay, here the sign notations means either plus or minus indications. Current entering and leaving indications here entirely different from the generators. Okay, that generator concept. Okay, well, because here this is like a DC motor. In this we are giving to the supply the motor. So motor ki ekkada supply istanamma, DC motor ki ekkada motor supply istanu. అదే మన జనరేటర్స్ కింద ఏం చేస్తానండి, మనం సప్లై తీసుకుంటాం. మనం జనరేటర్ సప్లై తీసుకుంటాం కాబట్టి అక్కడ మనకి సైన్ నోటేషన్స్ మారుతాయి, ఇక్కడ మన సైన్ నోటేషన్స్ మారుతాయి. మోటార్కి అయితే మనం సప్లై ఇస్తాం కాబట్టి ఎంట్రింగ్ అవుట్ నుంచి వస్తుంది మనకి. జనరేటర్కి అయితే ఇటు నుంచి మనం సప్లై ఇస్తాం, లోడ్ సెంటర్కి ఇస్తాం కాబట్టి సైన్ నోటేషన్స్ మారుతాయి. ఓకే, ప్లీజ్ రిమెంబర్ దట్. సో ఆల్ ఆఫ్ యూ, సో ఆల్ దోస్ థింగ్స్ వీఆర్ learning here also. Okay, so this is, let us consider this is like a rotor. The rotor may contains like armature. Okay, already know that, like A and AA. Okay, A and AA, and also one field winding is there. Okay, armature is there as well as one field winding is there. Already know that. So that is given as like this. So this is like a series motor. So that's why we have to represent it in series with the armature. This is like a series motor. Okay, so that's why the field winding which is connected in series with the armature, the field winding which is connected in series with the motor, when we are connecting like this, this is called as DC series motor, which is called as DC series motor, which is called as DC series motor. And also here we have to connect to the load also. Here we have to connect to the load also. Load is like a battery. Here load is like a some battery. Okay, battery. So with that battery we have to giving by this help of the battery we have to feeding some supply to the entire throughout the field winding as well as throughout the armature also. Why? Because this is the DC motor, we have to supply will be given to like this. Supply will be given from the load centers to motor. Load center means here load is like a battery, for example. Okay, so if it is like a generator, the supply will be given to the load center. The supply will be given to the throughout the armature and throughout the field winding and also given to the final load. But if it is like a DC motor, we have to give into the supply to the from the load or like some from the battery, we have to give into the supply to the entire winding like this. So the current will be flowing entire like this, entire loop. Okay, so please remember that, very very important that. As well as coming to the here. Okay, coming to the here, first of all this is like a load or battery, so that is indicated as plus and minus, similar which is represented to the like a DC generator concepts also. Okay, as well as here the current will be entering here. Here the current will be entering here. Why? Because supply will be given to the from this instant. So this is the plus. So that's why the current will be indicated like this. The current will be flowing like this. That's why which is indicated as plus and leaving from the field winding which is given as minus. Okay, as well as here also some in this is like a DC motor. So that's why in the DC motor generally produced as a back EMF. Generally produced as a back EMF. So that is given as EB. In case of DC generators, in the generator armature generally produces as a generated EMF. In that generator produces as a generated EMF will be produced in that particular armature. But in case of DC motor, in the DC motor generally produced to the back EMF. Generally produced to the back EMF. Very very important those concepts. Okay, so this is given as EB. So this is back EMF. EMF means that is like a, in terms of voltage. So that's why we have to indicate as like this. So doesn't changing the terminal indication. Okay, so which is similar to the like DC generator concepts also, plus and minus. Okay, as well as here also some armature winding is there. Here also some armature winding is there. So A. Okay, so like this here there internally like this will be there. This is A and this is A. So here current will be entering here current will be leaving and current will also again entering to the armature. So that's why we have to give it to the plus and this is the minus for the armature indication. So here the armature current and armature resistance also there. Already know that the armature may contains internally some current as well as internally some resistance property also. Okay, that is given as Ia into Ra. Ia into Ra. Ra means armature internal resistance as well as some current will be flowing through the armature. A means armature here. Okay, that is given as Ia. That is given as Ia. Okay, Ia into Ra. So that is given as plus and minus. Because current will be entering like this. That is indicated as plus and minus. Okay. So anyone is there? No one is there. Okay. This is the series field winding. This is given as, okay, this is the series field winding. So this is given as Isc into Rsc. You already know that Isc into Rsc according to the generated equations. Generated construction equation. Okay, so this is the total representation for the DC series motor. Okay, so coming to the applying KVL to the entire loop. Coming to the applying KVL to the entire loop. Okay, applying KVL. KVL means Kirchhoff voltage. KVL means Kirchhoff voltage. Okay, so KVL apply చేస్తే ఏమవుతాం మీకు చెప్పండి అమ్మా. So minus V. Okay, here minus V. This is the load. So load means that is like a V. Load voltage are like a band means which is given as V. Okay, so minus V. What happened here? Minus V. So here you have to take into the second terminal. Please remember that very important. If you want to consider the first terminal, all those terminals we have to take into the first instant only. Okay. For example, if you want to take into the second instant, so all those different types of components we have to take into the second instant only. Okay. So this is the very important. Okay. So here for simple concept, for simple shortcut method, so for the simple calculation for the all those equations we have to take into the second terminal indication. So second terminal instant, that is given as minus V. Okay, minus V. Then what happened here? Minus V. This is the first one. This is the second one. So plus Ia into Ra. Plus Ia into Ra. So for the armature plus Ia into Ra as well as, so here back EMF is there. That is given as plus Cb. That is given as plus Cb. Why? Because first one, this is the second instant. That is given as plus Cb as well as coming to the here field winding. So this is the first one and this is the second one. Okay, so that is given as plus Isc into Rsc. Plus Isc into Rsc. I think you are understood what I am saying. Okay, here according to the, so here current notation is already we can indicate it. Okay, so how to current flowing to the entire circuit we have to indicate it like this. Okay, but we have to apply the KVL. So I think you may contain some doubt. Here indicated like this direction, current direction, but you have to take, how you have to take the loop direction here. So this is the loop direction. So any direction we have to take. Loop direction can be, we have to choose the any direction like this path as well as like this path. Any direction we have to take. So finally you can get to the same answer. Okay. If you want to check once again, you can clearly understood. Okay. So here minus V plus Ia into Ra plus Eb plus Isc into Rsc. This is the total back EMF equation for the DC motor. Okay. Here if you want to calculate the back EMF Eb, so Eb is equal to what happened here? V plus, okay, Eb is equal to V plus Ia into Ra. So V minus Ia into Ra minus Eb minus Isc into Rsc. Okay, Eb is equal to V minus Ia into Ra. So total term we have to shift into outside. V minus Ia into Ra minus Isc into Rsc. So from this equation, Eb is equal to V minus. Okay, here already know that the total field winding current, how much amount of current will be flowing to the field winding, that current will be equal to the armature winding also. That total current will be equal to the armature winding on the rotor also. Okay, so that is given as Isc is equal to Ia here. Isc is equal to Ia, similar to the in case of DC series generator. Okay, Isc is equal to Ia. So if you want to replace the instead of Isc, so then what happened? Ia, if you want to common Ia, Ra plus Rsc. Okay, so instead of Isc, if you want to replace the Ia, then what happened? So take the common Ia, so then Ra plus Rsc. This is the equation, total back EMF equation for the DC series motor. This is the back EMF equation for the DC series motor. Okay, which is very important. Okay, as well as also we have to here, so adding to the some brush conductor of also, that is given as like a either B1 and B2, like B1 and B2 are like are also called as like a some BCD. What are maybe that we have to indicate it to the total back EMF equation for the DC series motor. Okay, so this is the total DC series motor. So coming to the DC shunt motor, DC shunt motor. Okay, some small variation is there here. Okay, some small variation is there here. So coming to the shunt motor, so how can you judge the shunt motor? Simply you can say that the field winding which is connected across the terminals, when we are connecting to the field winding which is connected to the across the both armature terminals, that is called as DC shunt motor. That is called as DC shunt motor. So let us now we have to draw the construction. Okay, total construction. Okay, so coming to the total construction here. Okay, coming to the total construction here. So this is the motor rotor. Here also the field winding. Okay, this is A and this is JA. Okay, I already know that. Here the field winding which is connected across the both armature terminals. The field winding which is connected across the both armature terminals like this. Okay, so then only it is called as DC shunt motor. Okay, here field winding is across connected to the armature terminals. Okay, as well as here load also connected. As well as here some load also connected like this. Then it is called as DC shunt motor. Then it is called as DC shunt motor, which is very very important. Okay, so this is like play load. So that is indicated as, we already know that. So this is a shunt field. This is like a shunt field that is given as ISH into RSH. Okay, shunt field current will be given as ISH, and the internal some resistance property is there, that is given as RSH. Okay, how can we draw the SH? SH means here shunt. Okay, R means resistance. Okay, here also I means some current will flow into the entire winding. Here SH means shunt, ISH. Okay, like this. Okay, so this is a total equation, total representation diagram. So if you want to calculate the total back EMF equation in that particular DC shunt motor, so then what we have to get here? So let us now we have to learn here. Okay, so applying KVL to the entire equation, applying KVL to the entire loop. So here the KVL which is applied only at load side only. Already know that. Okay, I think. So we doesn't apply to the field winding side. Okay, only we have to apply to the in any machine, in any construction point of view. Either in case of DC machines, DC machines means either DC generators as well as either DC motor. We have to only calculate the back EMF equation or either generated EMF equation only at load side only. Why? Because here the supply will be either sharing or also called as either feeding or either receiving. So total will be existing in that only load side. So that's why we have to calculate the both EMF equations only at load side only. Both EMF equations at load side only. Okay. So let us coming to here applying KVL here. So from this voltage here to give it to the minus VR. Okay, here to take the here also we have to take into the second instant only. So minus V. Okay, as well as this is the armature. This is indicated as, so current will be flowing like this similarly. So current will be because supply in the supply is current flow already. So that is because plus or minus. Okay, so minus V. Okay, minus V, as well as this armature is there. So that is given as plus IA into RA, as well as some back EMF is there, that is indicated as plus or minus. So that's why plus EB. Okay, so that's enough. No extra elements is there. Okay, only back EMF, IRA and voltage. So total will be like this. So from this instant of equations, what we have to get to the final back EMF equation from the DC shunt generator, not shunt motor. Okay, here EB is equal to V plus. Okay, here EB is equal to V plus. Okay, plus means V minus IA RA. Okay, that's enough. EB is equal to V minus IA RA. From this total equation, EB is equal to V minus IA RA, as well as some brush contact drop also is there. So already know that. So there is given as some BCD. So this is the equation for the DC shunt motor. Okay, very very important. Okay, as well as coming to the DC compound motors, Okay, let us know we have to go discussing about DC compound motor. Okay, if you want to go for the DC compound motor, here the compound, in that compound motors may contain both long shunt compound as well as short shunt compound motor. Already know that. Okay, I think. Okay, so coming to the long shunt compound motor, Okay, coming to the long shunt compound motor. Okay, here first of all we have to draw the rotor. Okay, here long shunt, coming to the long shunt motor, basically in this may contains both two field windings as well as one armature winding, similar to the in case of DC generators. Okay, in this may also contains two field winding as well as one armature winding, both long shunt compound motor as well as both short shunt compound motor. Okay, please keep that point very important. So coming to the here, so this is the rotor. The rotor may contains A and A like armature terminals, as well as so in series with the armature. In series with the armature, we have to draw the one field winding. We have to draw the one field winding. Okay, another field winding which is connected one end of the series field winding as well as one end of the series field winding. One end of the series field winding as well as another end which is connected to the another armature terminals and another armature terminal end of the rotor. Another armature terminal end of the rotor. Okay, so this is the construction of long shunt compound motor. This is the construction of long shunt compound motor. Okay, here also we have to connect to the across the total. So we have to connect to the load here also. Here also we have to connect to the load. Okay, this is the total construction of long shunt compound motor. Okay, here also we have to receive the supply from the load or else like a battery. Okay, so current will be flowing like this through the field winding, through the armature, like this to the entire motor. Okay, in this back EMF also produced, that is given as plus and minus. Okay, current will flowing like this. Okay, so this is like IL, for example, let us consider. So this is the ISC into RSC. Series field winding means this is ISC into RSC, as well as this is the shunt field winding. Okay, that's why we have to represent it ISH into RSC. That's why we have to represent to the ISH into RSH. Okay, so coming to the what happened here in the terminals. So this is the load, so that is indicated as either plus and minus. This is the load voltage which is given as plus and minus. So that's enough. Okay, so coming to the applying KVL to the entire loop, at load side only we have to calculate. Already know that, I think. So applying KVL at load side, then what we have to get here? So minus V here, minus V. Okay, minus V. Then what happened? Plus EB. Okay, plus IARA plus IRA. And some resistance is there, some armature resistance, that is given as IA into RA, as well as some current is there. So here entering plus and leaving negative. Okay, here taken to the second incident. That's why here taken to the plus. Okay, that is given as plus ISC into RSC, So this equation will be coming to the like a DC series motor. If you observe this total diagram equation representation, so this equation will be coming to the like a DC series motor. Okay, so if you observe this coming from this equation, so finally you can get to the EB is equal to V minus IA into RA minus ISC into RSC. Okay, so this is the equation for the back EMF equation for the long shunt compound motor. Okay, so from this equation we have to write like this here. Okay, from this equation we have to write, okay, here from this circuit diagram. Okay, here ISC is equal to IA. Why? Because both series field winding as well as armature which is connected series. So that's why here ISC is equal to IA. Okay, so from this equation, if you want to substitute instead of ISC to IA, so then we can get to the EB is equal to V minus IA. If you want to take the common IA, okay, RA plus RSC. Okay, so this is the final equation for the back EMF for long shunt compound motor. Okay, and also for example, if we want to find out the current here, okay, IS is equal to V by RSH. Okay, so this is the load voltage V by total field current will be here given as ISH, and also resistance is RSH. According to Ohm's law, IS is equal to V by RSH. Okay, so this is the long shunt compound motor current equation as well as back EMF equation. Okay. So if you want to go for the short shunt compound motor, so the long shunt compound motor can be, if you want to do the small modification, then we can get to the short shunt compound motor. Modification of long shunt compound motor. Okay. Here for example, the field winding. If it is connected across the both armature terminals, then we can get to the short shunt compound motor. So this is the representation for the short shunt compound motor. Okay. So from this instant of total diagram, we can get to the back EMF equation also. Back EMF equation also. So representation is same. Representation is sign notation is same. Okay. So from this equation, so total diagram, we can get to the equation is minus V. Okay, minus V as well as plus EB. Okay, plus EB as well as current will be entering here like this from this direction. That's why plus IARA. Okay, as well as current is entering from the field loading here. So that's why plus ISC RSC plus ISC RSC. This is the total resultant equation for the short shunt component motor. Short shunt component motor. Okay. So according to from this equation, so finally we can get to the back EMF equation also. Back EMF equation also. Okay. Here EB is equal to what happened here? V minus IA into RA minus ISC into RSC minus ISC into RSC. Okay. EB is equal to V minus IRA minus ISC into RSC. Here from EB from this equation we can get. Okay. So this is the final back EMF equation for the short shunt component motor. Short shunt component motor. Very very important. Please remember this. Okay. Please remember this. Very very important for the all back EMF equation for the DC motors. Okay. And also if you want to calculate the so this is the back EMF equation. This is the back EMF equation. Okay. If you want to calculate the current, what happened here? ISH is equal to what happened here? What happened here? ISH is equal to ISH is equal to what happened here? ISH is equal to V plus ISC into RSC. ISH is equal to ISH is equal to V plus ISC into ISC is equal to V plus ISC into RSC by RSH. So this is the shunt field current calculation in case of short shunt component motor. This is the shunt field current calculation for the short shunt component motor. Why? Because here the load voltage or battery which is connected in series with the field winding, that's why you have to indicate V plus ISC into RSC. Okay, by RSC shunt field current. Okay, according to Ohm's law, we have to represent it to the shunt field current here. Okay, and coming to the last one is the separately actuated DC motor. Separately actuated DC motor. Okay, separately actuated DC motor. So in case of separately actuated DC motor, all you know that both field winding as well as armature winding which is entirely separate or isolate. Okay, so simply we have to represent like this. Okay, in this we can't calculate to the any generated back EMF, Why? Because this is not suitable for any type of industrial application. Mostly we have to prefer to the only both series motor and shunt motor and compound motor only. Like self-actuated DC motors only we have to prefer, not we have to prefer to the like a separately actuated DC motor. That's why here we are not calculating to the back EMF equation. Okay. So coming to the here, so simple construction representation. Okay, this is A, this is JA. So here supply will be given here individually. That is like a some V volts. Okay, this is the armature like this. As well as another field winding is there. This field winding we have to give it to the supply separately. We have to give the supply separately. Okay, so this is called as from this representation like separately actuated DC motor. This is the separately actuated DC motor representation. Okay, what total representation will be given as? So here field winding separately connection we are field winding. For field winding we are given to the separate supply voltage, as well as for armature winding we have to give into the separate voltage. So that's why this is called as separately actuated DC motor. Here we are not the back EMF equation is calculated. Why? Because both windings are isolated. That's why. So this is not suitable for any different types of load applications. Okay. So this is the today our class, subscribers. Okay. If you have any doubt, okay, please put on the our comment box. Okay. So please go to daily our channel. Okay. So see the different types of new concept oriented classes. Okay. I need your support. I please encourage to me. Okay. So thank you very much. Thank you.